Okay, get this. We're diving into something massive today.
Oh, yeah.
Yeah, it's called BIOMEDICA, and it's all about AI and medical research.
Hmm. Using AI to unlock all those secrets hiding in research papers.
It's like having the Library of Congress at our fingertips, but just for medicine.
Wow, it's a lot of information.
Oh, it is. It's huge. Think 24 million image and caption pairs.
Wait, seriously?
Yep, and all pulled from like over 6 million articles.
Okay, hold on. So this isn't just a, simple image search. We're talking about a whole system.
Exactly, a perfectly organized library of research.
That could change everything for researchers. I mean, they usually spend so much time digging through all those papers for, like, one specific image or figure.
I know, right? And the best part is it covers so much ground.
Yeah.
Remember that figure from the paper, the one showing how Biomedica maps onto all those different areas?
Oh, right. It's not just one tiny part of medicine.
Nope, it's everything from analyzing cells under a microscope to like how genes affect our response to medication.
Oh, wow. Most data sets are way more limited.
Exactly. They usually just focus on one thing, like x-rays or tissues.
This is way bigger. Biomedica's scope is massive.
Totally. So, how do they even build something this big?
It's a process.
I bet it is. Where do you even start with 6 million articles?
Well, first they had to gather all the ingredients. Like images, captions, all those references, all from millions of articles.
Okay. And then
Then they had to make sense of it all.
that sounds like a job for like a whole team of experts.
Oh, absolutely. It was a massive collaboration.
Yeah.
Doctors, scientists, geneticists, everyone.
Wow, that's amazing.
It was.
So they had this giant data set, but I'm guessing there were some challenges along the way.
Oh, for sure. Building something this big is never easy.
What were some of the hurdles?
Well, one of the big ones was dealing with all those different image sizes. Some are tiny, like thumbnails, and others are huge, high-res pictures.
Oh, I see. So trying to teach an AI model to recognize things when the images are all different sizes.
Yeah, that's not easy.
And what about all the text? Didn't they mention something about the AI model having limitations with how much text it could handle at once?
That's right. It's like it has a limited capacity for reading.
Like trying to read a whole book through a tiny peephole.
Exactly. And some of those captions are longer than the model can handle, so some details might get lost.
That makes sense. But didn't they say Biomedica has more information attached to each image compared to other data sets?
They did. It's like a whole backstory for each picture.
Okay, so they built this huge data set. Then what? Did they just let it sit there?
Nope. They created a suite of AI models, BMCA CLE P, and used this really cool technique called continual pre-training.
Continual pre-training.
Yeah, it means they can train the models without downloading like all 27 terabytes of data at once.
Oh, wow, that's a lot of data.
Yeah, imagine needing that much space just to get started.
So, how did they actually train these models? Did they just feed them everything at once?
Actually, they tried a few different things. Sometimes they used the whole data set. Other times they focused on specific areas.
Oh, interesting. So, like different learning strategies.
Exactly. It's like some people learn best in big groups. Others need more one-on-one time.
That makes sense.
And it turns out focusing on specific areas actually worked better for the models.
So they basically became specialists.
Exactly.
This is blowing my mind.
It is pretty amazing.
How good are these models? Like, do they actually work?
That's what we'll be exploring in part 2.
Mhm.
Get ready for some seriously impressive results.
Ooh, can't wait.
Yeah, these BMCA CLE models are already doing some incredible things.
All right, listeners, we're just getting started.
This is going to be good.
All right, so last time we were talking about Biomedica,
Right, that massive data set.
like a medical library of Congress all ready for AI,
And we talked about all those millions of images and captions.
and how they labeled everything.
Oh, and those super smart BMCA CLEP models.
Yeah, those are pretty cool, but how do we know if they actually work?
Well, that's the fun part, putting them to the test.
Did they, like, create a challenge for them?
Exactly, almost like an obstacle course with 40 different tasks.
Wow, 40. What kind of tasks?
Everything. Analyzing slides, interpreting x-rays, even helping plan surgeries.
Wow, that's a lot. So they really pushed them to the limit.
Oh, yeah, and remember how we talked about most evaluations only focusing on, like, a few areas?
Right.
Well, this time, they wanted to see how these models did across the board.
So a real test of their abilities.
Exactly.
What were some of the standout moments? Anything really impress you?
One thing was how different training approaches led to different results.
Oh, right, like feeding them all the data at once versus focusing on certain areas?
Yeah, exactly. And it turns out specializing paid off.
Really?
Yeah. The model trained specifically on clinical imaging, the BMCA CLE IPCF.
Right.
It consistently did better than the others, especially in tasks related to dermatology.
So by narrowing their focus, they got better results. Makes sense.
And the results were pretty dramatic.
Like how dramatic?
Well, in dermatology, this model showed a 53% improvement over the previous best model.
Okay, that's huge. More than 50% improvement.
Right. Think about that. Faster and more effective treatment.
That's incredible. What about the other models? How did BMCA KLI PCF compare?
It pretty much outperformed all the top models, even the ones considered the best.
Wow, so it's like a high-performance car, but even better.
And get this, it did all this using less computing power and data.
So it's not just brute force, it's efficiency too.
Exactly. But, no model is perfect.
Right. Were there any limitations or challenges they ran into?
Well, one of the big ones, and we talked about this earlier, is the limited capacity to handle large chunks of text.
Right, like that peephole analogy.
Exactly. So for longer captions, it might miss some important details.
I see. So even with those limitations, BMCA CIP is still promising.
Oh, absolutely. It's a huge leap forward.
So they've given researchers this amazing toolkit.
Access to this massive library of medical knowledge.
And these powerful AI assistants to help make sense of it.
Exactly.
So, how does all this translate into the real world? How can this actually make a difference in people's lives?
That's the big question, isn't it? That's what we'll be exploring in part 3.
Okay, I'm intrigued. What can we expect?
We'll be talking about faster drug discovery, more accurate diagnoses, even personalized treatments.
Wow, that sounds amazing.
It is. Get ready to be amazed by the potential of Biomedica.
All right, listeners, stay tuned. It's about to get really interesting. Welcome back to the final part of our deep dive. We've talked about the huge scale of Biomedica, those smart BMCA clip models.
Yeah, and how they're already outperforming some of the best AI models out there.
But how does all of this translate to real-world results? Like, how can Biomedica actually make a difference in people's lives?
Well, that's the goal, right?
Yeah.
To go beyond just research.
Exactly.
And honestly, the possibilities are pretty amazing.
Like what? What are some areas where Biomedica could really shine?
Well, let's start with drug discovery. Imagine using these AI models to speed up the process of finding new drugs.
Right, so they could sift through all those research papers and find, like, potential drug targets or new therapies.
Exactly. It's like having a superpowered research assistant who can read 1,000,000 pages a minute.
That could save so much time. I mean, drug development takes years, right?
It does. And it's not just about speed. It's about being more precise.
How so?
Well, these AI models could help us find those subtle connections, the things humans might miss, leading to more targeted treatments.
Oh, I see. Like an AI detective?
Exactly. And speaking of detectives, Biomedica could also revolutionize diagnostics.
Oh, yeah.
Think about those AI models analyzing medical images, like X-rays or CT scans, even biopsies.
Right.
They can help doctors make faster and more accurate diagnoses.
Especially in areas where there's a shortage of specialists.
Exactly. And it could help reduce misdiagnosis.
Which is a big deal.
Oh, yeah. A lot rides on getting the right diagnosis quickly.
Definitely. What about personalized medicine? We talked about how Biomedica has information about genes and medication response. Could this help create, like, custom treatments?
Absolutely. By combining genetic info with medical history, these AI models could help doctors predict which treatment is best for each patient.
Wow, that's like having a custom-made suit, perfectly tailored.
It is. It's really incredible.
And it's not just for individuals,
Yeah.
right? Biomedica could help with global health challenges, too.
Oh, yeah, for sure. Things like tracking the spread of diseases or identifying areas for public health interventions.
It's like a worldwide early warning system.
Exactly. And these are just a few examples. I'm sure we'll see even more applications in the future.
So as we wrap up this deep dive into Biomedica, what's the big takeaway for our listeners?
I think Biomedica really feels like a turning point in medicine. It's a whole new toolkit for researchers.
A vast library of medical knowledge and these powerful AI assistants.
Right. The potential to improve human health is enormous.
Well, that's a wrap on another deep dive. We hope you enjoyed exploring the world of Biomedica with us. Until next time, keep learning, keep questioning, and keep diving deep.